So we're going to identify the roots of a polynomial. We're going to learn a new procedure for doing that. Please follow along with me in example number 1. We want to know the maximum number of possible. So we're making a prediction, the number of possible real roots. Real roots, by the way, if you want to please write this down, real roots are going to refer to the x-intercepts. Real roots are referring to the x-intercepts, and they have no i's. They're your solutions with no i's, and they are the x-intercepts on the graph. So this is the possible number. It's not a for sure. This is the maximum number of possible. Maximum number of possible complex would be your solutions that contain i's. Remember, they do come in pairs of 2. So to do that, I am going to focus on the degree. This is degree 3. That means there's a maximum of a possibility of 3 real roots. That's the maximum, the most. It could have 0, 1, 2, or 3, 3 being the maximum. The maximum number of complex would be 2. I can fit 2 i's into 3, knowing they come in pairs of 2. Here's the new part that's really confusing for a lot of students. We're going to start with the back. And I'm going to put down all the numbers that divide into 12. So 1, negative 1, 2, negative 2, 3, 4, 6, 12. All of those integers divide nicely into negative 12. And I'm going to do the exact same thing with the leading coefficient of 1. 1 and negative 1. There's more than one way to do this, but right now I'm going to start by listing all the possible rational roots, and then I'm going to go back and simplify them. So to do that, the back number, the possibilities we have, always goes on the numerator on top, and these always go on the bottom in the denominator. So watch, I'm going to take this 1, I'm going to write it down twice because there's 2 numbers in front, 1 and negative 1. Then so I'm done with that one. Then I'm going to write down negative 1 twice. Negative 1 on top, negative 1 on top, and put a 1 and a negative 1 on the bottom. Then I'm going to write 2 twice. 1 and negative 1 on the bottom. Negative 2 twice. Yes. Please do that right now. After I've written down all the possibilities, now I need to reduce it. So I need to come up with an exact list of possible rational roots after each fraction has been reduced. So I know 1 over 1 is equal to 1. So I'm going to use a different color writing utensil so it stands out. So anything that's a 1 I am going to cancel out. So I'm going to simplify all the 1s. Okay, here's a 1. I already have it. Okay, those are the only 1s. Okay, here's a negative 1. Another negative 1. Here's a 2, and another 2, negative 2, and I can see the pattern. I have 3 and negative 3, 4 and negative 4, and I can see the pattern continue. So I have 6 and negative 6 and 12 and negative 12. So how many actual possible rational roots could there be? Doesn't mean these are all the answers. These are the possible rational roots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible rational roots. So yesterday we learned about polynomial long division. Today we're going to learn about something called synthetic division. So if you had to Google this and watch a video, it's called synthetic division. I refer to it as the MAMA method. And the MAMA method uses the operation, first I multiply, then I add, then I multiply, then I add. And I continue that pattern knowing that if I ever multiply, I have to follow it up with addition. So I'm going to start off with number 1. I'll go slowly through this. And I'm trying to find out which one of these roots works. I'm going to make an upside down division box. And then I'm going to find out, in this original function, what degree is it? That means what is the highest number on a variable? 3. Okay, so really small, like miniature size, I'm going to go 3, 2, 1, 0. And that just allows me to ensure that if there is a missing piece to the function, that I put a variable, I put the numerical number 0 there. Okay, so I look up top, 1 goes with x cubed, 2, negative 11, and negative 12. So we are ready to start the mama method. So let me first say this. When we do the mama method, and I say multiply every single time, the number that's out front is going to be the number we multiply with. When I say add, we go straight down. So before we can get started, it's kind of like you can't start a car without the keys inside. You have to put a 1 down below. Can't do anything without a 1 down below. Here we go, mama. Start with multiplying. So 1 times 1 is 1. Now I'm going to move to adding. When I add, I go straight down. 2 and 1 is 3. Go to multiplying. Everything always goes back up here. 3 times 1 is 3. Add straight down to get negative 8. Back to multiplying. Negative 8 times 1 is negative 8. And A, we always finish with adding, is negative 20. If this number is not 0, that means 1 is not an answer. That's not an answer that works. Let's try negative 1. Put a negative 1 out front. And now that we already have seen that nothing's missing, let's just write 1, 2, negative 11, and negative 12. Bring down the very first number. Okay, mama method, M for multiplying. As a reminder, every time we multiply, it's the outside number. So, 1 times negative 1 is negative 1. Add straight down to get 1. M for multiplying. 1 times negative 1 is negative 1. Add straight down to achieve negative 12. Negative 1 times negative 12 is 12. Add straight down to get 0. We're in luck. We found an answer. What does this mean? It means this answer works. Can I rewrite x equals negative 1? Put a big circle around it. I need to get 3 answers. Some of them may duplicate, but I need 3 answers. And I'm now going to use this piece to see if I can get the next 2 answers. So 0 equals, and we're going to write this backwards. So this has no x's, always no x's on the opposite side of the 0. No x's, 1x, 2 x's. Is it possible to factor this? That will always be the easiest way if it's possible. Do we know 2 numbers that multiply to equal negative 12 and combine to give you 1? Multiply equal negative 12 combine to give you 1. Do we know that?
3 and 4.
Okay, what are the symbols on the 3 and 4? Okay, set it equal to 0. So x plus 4 equals 0 and x minus 3 equals 0. That means one answer is negative 4. The other answer is positive 3. I was supposed to come up with 3 answers, and I found all 3. All 3 do not have an I. That means down here there are 3 reals and 0 complex. How do I write this in factored form? Well, this original problem is f of x, so this is just another form. F of x equals, I'm going to put down 3 parentheses for the 3 factors, and it doesn't matter the order I'd write them in. Remember, when we put them on the inside, it's opposite of what you think. X plus 1, x plus 4, x minus 3. This is an odd degree with a positive leading coefficient. Odd degree, positive leading coefficient. Odd degree, so if it's even, they're both up or they're both down. Odd, they're going in opposite directions. So this is odd, they're going in opposite directions. Remember, your right hand always tells the truth. Right hand is positive. It means it's going to be up on the right and down on the left. Up on the right, down on the left. Please draw a very simple graph. We're going to do a sketch. And I'm going to start by identifying our solutions. So negative 1, 2, 3, negative 4, and positive 3. Negative 1, negative 4, and positive 3. And remember, I can easily identify the y-intercept as negative 12. So go all the way down here, we're going to estimate, here's negative 12. Now we just said up on the right, down on the left. Remember, this is a sketch. So I'm going to go through the 3, pick up the negative 12, back up, and over. That means that this end behavior is I go to the right, so as I go to the right, it's going up. As I go to the left, it's going down. Example 3, I am changing the order in which we go through these. The maximum number of possible, remember this is not absolute, possible solutions. Okay, how do I figure this out? I'm going to look at the degree of the problem. So there's 3 possible, that's a maximum. So it could be 0, 1, 2, or 3. That's a maximum. The maximum possible of complex is 2. The numbers that divide into 2 is 1, negative 1, and 2 and negative 2. Into positive 1 is 1 and negative 1. Now there's more than one pattern to how you do this. Here's how I prefer to do it. I'm going to write 1 twice. 1 and 1. And write negative 1 twice. Negative 1, negative 1. 2, hold on here. 1, 1, 2 and 2, negative 2 and negative 2. 2, 2, 2, and 2, okay? Then underneath I'm going to do 1, negative 1, 1, negative 1, 1, negative 1, and 1, negative 1. And now I'm going to go back and I'm going to simplify. I want to change that. Simplify the fractions. 1 divided by 1 is 1. So anything with a 1 I cancel out. This is negative 1. Anything with a negative 1 I cancel out. This is 2 and negative 2. Begin the Mama method, also known as synthetic division. One times 1 is 1. 1 times, then add down to get 2. 1 times 2 is 2. Add down to get 0. 1 times 0 is 0. Add down to get negative 2. I just want to make sure my math is correct. Multiply, add, multiply, add, multiply, add. I'm going to try negative 2 now. Multiply, add down, multiply, add down, multiply, add down. Okay, try negative 1. Multiply, add down, multiply, add down, multiply, add down. So I did negative 1. Negative 1 works. What does that mean? That means x equals negative 1 is an answer. Please put a big circle around that. X equals negative 1 is an answer. So remember, I'm going to write down 0 equals no x, 1x, 2x. And normally I'd say factor this, but what's 0 times x in the middle? It's just 0, right? This is just 0. 0 times anything is just 0, and 0 minus 2 is negative 2. So I have 1x squared minus 2 equals 0. I'm going to use simple algebra to solve. I'm going to add 2 to the opposite side. Take the square root. I know dividing by 1 doesn't change anything. And I get x equals plus or minus the square root of 2. I already have 3 answers. X equals negative 1, x equals the square root of 2, and x equals the negative square root of 2. None of these answers contain an I. That means I have 3 real roots and 0 complex. Factored form. H of x equals x plus 1, x minus radical 2, x plus radical 2. This is an odd degree with a positive leading coefficient. Can you please do me a favor? Grab a calculator and please put in the square root of 2. What is the square root of 2 equivalent to if you rounded to the nearest, let's go to the nearest 10th. Can anybody please share with me? Square root of 2. Approximately what? 1.4? Okay, so here we go. I'm going to find negative 1. So negative 1, make a dot. I'm at 1.4 approximately. I'm going to write square root of 2. And negative 1.4 square root of negative square root of 2. In this problem, my y-intercept occurs at negative 2. And now I have odd degree, positive, leading coefficient positive. So I'm coming up on the right and down on the left. I'm doing a sketch. Come down here, grab the y-intercept, back up, and over. End behavior, as I go to the left, it's going down. As I go to the right, it's going up. So I came up with 6 possibilities. Can you raise your hand if you were able to find 6 possibilities? Okay. And now I'm going to test them. You're welcome to share out testing to find one that works. It took me to my 4th attempt till I got one that worked. So I came up with x equals -2 works. So I write down 2x squared plus 1x plus 1 equals 0. And I realized I can't factor this. It was common in other classes to think you could, because you're going, okay, what multiplies to equal 2 and combines to give you 1? You can't find two numbers that multiply to give you a positive 2 and combine to give you a positive 1. What do you do when you have to solve but factoring doesn't work? You rely on the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I know 4 times 2 is 8, 8 times 1 is 8. So 1 subtract 8 is a -7. Cannot take the square root of a negative, so x equals -1 plus or minus I times the square root of 7 over 4. How many answers exist right here? How many answers exist right here? 2, one positive and one negative. One with addition, one with subtraction. Here's 2 answers. They're complex because they have an I. Here's one answer. It is real. So I still am getting 3 answers, 1 real and 2 complex. So how do I write this in factored form? G of x equals x plus 2, and then we can bump back up to this part when we weren't able to factor this and write 2x squared plus 1x plus 1. Factored form, identifying what type of roots. This is odd, and it is a positive leading coefficient. I'm going to draw a very simple graph. I'm going to go up to positive 2 on the y-intercept and make a dot because 2 is my y-intercept. The only real answer I have occurs at -2. And you may be thinking, like, what about these? Remember, when you're graphing on a coordinate plane, a real coordinate plane, the I answers don't show up. So I know it needs to go up to the right, down to the left. So it's going to be something like this. Up to the right, down to the left. Up to the right, down to the left. As I go to the right, I go up. As I go to the left, I go down.